Hi, in this series of videos we're going to be looking at GCSE Maths walkthrough. Each of the playlists is going to be about 4 or 5 videos. Each video will be about 20 minutes long. Please do stop the video, have a go at each of the questions and then compare your solutions. If you do need any help, please add a comment below. I'll always come back to you. I look forward to seeing you inside the next video. Hi, this is the second video in the playlist where we're looking at the June 2018 and it's paper 3. In the previous video we completed through to question number 9, so in this one we're going to start from question number 10 onwards. Okay, I'm going to aim for roughly about 20 minutes or so on this particular video. Please do stop, have a go at each of the questions. Okay, so question number 10, a little bit tricky. The nth term of a sequence is that. Work out the numbers in the sequence that have 2 digits and are not prime numbers. Okay, it's one of those questions where I think you've just got to kind of have a go at this, really. So what we're saying is the first term is where n equals 1, or the first number is where n equals 1. So I'm going to write this as n equals at the top. I'm going to say 1. Okay, so when n equals 1, I can plug it into this particular equation and I get 12 times 1 minus 5, which equals 7. All right, no problem. So let's carry on with that. Let's see if we can come up with 2-digit numbers that are not prime numbers. So let's have a look at when n equals 2. So we've got 12 times 2 minus 5. Okay, and that's going to give us 19. Well, actually 19 is a prime number because it's not divisible by anything. Okay, so let's have a look then at when n equals 3. I'm afraid this is probably going to be quite a tedious sort of answer on this one. It will take a little bit of working out. Okay, so I won't describe each of the operations, but I'm sure you'll be able to follow this. Okay, now at the moment we've got a whole bunch of prime numbers. Okay, however, when we get to this number, which is when n equals 5, we get a number which is not prime. It's 55. Now 55 is not prime because it's in the 5 times table or the 11 times table, because actually that's going to be 5 times 11 is 55. Okay, so that's our first number. Let's have a look at 6. So I've got 12. 6 minus 5. Okay, well that's going to be 67, which is prime. 7. 12 times 7 minus 5, that's going to be 79, and then 8, and that's 12 times 8 times, minus 5, which is going to be 91. Now, actually, 91 is also not a prime number. Okay, we could carry on this forever, but basically they want us to work out two numbers where they're 2 digits and they're not prime. Okay, so let's have a look then. The reason 91 is not prime is because that's equivalent to 7 times 13. Okay, and as we mentioned before, this is 5 times 11. Okay, so unfortunately, it's one of those questions where you could go whizzing past that and go off into, 9 times and 10 times, 11 times and all the rest of it. You've just got to kind of stop and keep sort of recognizing that there are numbers in there. Otherwise, they wouldn't be asking the question. And probably for a 3 marker, they probably don't want you to go too far working out all of these into sort of like 14, 15 value of n and all that sort of stuff. Okay, so the 2 numbers are 55 and 91. Bit of a tedious question, I'm afraid. It's just one of those ones that you just got to kind of work through. Okay, let's have a look then at question number 11, which is dealing with matrices. Okay, now matrices are just a representation of matrices or vectors. Okay, so in this particular one we're going to work out a plus b plus c. So all we're going to do is we're going to add the lines along on each of these. Okay, so we've got a is going to be 6 plus minus 1 plus minus 4. Okay, so that's going to be 6 minus 1 minus 4 is going to be 1. Okay, and then the second line is going to be minus 10 plus 2 plus 7. Okay, so minus 10 plus 2 plus 7 is going to be minus 1. So the answer is going to be 1 over minus 1. That's it for that particular question. It's only a couple of marks. Okay, so the next one is show that A plus 2C is parallel to B. In other words, it's parallel to this vector over here. Okay, so A plus 2C, let's have a look at that then. I wonder how I can put this on the screen. I'll do my best for you. Okay, so A is going to be 6 over minus 10. Okay, hopefully you can see that just at the bottom corner there. And 2B, sorry, beg your pardon, 2C is going to be 2 times minus 4 over 7. Okay, well 2 times minus 4 over 7 is going to be minus 8 over 14. Okay, and if I add those two together, I've got 6 plus minus 8 is going to be minus 2, and then minus 10 plus 14 is going to be positive 4. Okay, now if I divide that by 2, hopefully you'll see that I can have it as parallel because it's going to be exactly the same as vector B. Okay, hope that's all right for you. Let's move on then to question number 12. So question number 12 is a question relating to pressure is force over area. Force of 40 newtons is applied to an area of 3.2 square meters. Work out the pressure. Well, basically it's a calculator paper, so hopefully you'll just be able to pop into your calculator 40 over 3.2 is equal to 12.5. Now that actually will get you 1 mark, because the second part of that, it says give the units of your answer. Well, the units are going to be newtons, remember force is in newtons, over or divided by square meters. Newtons per, remember per means over meters squared. Okay, so the force is going to be 12.5 newtons per meter squared. Okay, hope that's all right for you. Then it says question number 13, tick all the statements that are true for any rhombus. Okay, well, a rhombus is basically like a parallelogram shape, but actually all the sides are the same and two sides are parallel to each other. Okay, so that's a rhombus. Okay, so the diagonals are lines of symmetry. In other words, if I, although I've not drawn it particularly well, but if I put a line through there and folded it in two, both sides would be the same. And again, if I put a line through there and fold it in two, both sides would be the same. So the diagonals are lines of symmetry. Okay, the diagonals bisect each other. Well, yes, they do. Bisect just basically means cut in two. So they do, even though my drawing's not great. And then the diagonals are perpendicular. In other words, they're both at 90 degrees to each other, which, had I been a better artist, then perhaps that would be true on this particular drawing. Okay, hope that's all right for you. Let's move on then to question number 14. Now, question number 14 asks us to draw a graph, and the value is y equals 0.8 to the power of x. Okay, values of x from 0 to 6. So basically all we're doing is plugging this information into a calculator. So 0.8 to the power of 0 is going to be 1, because any number to the power of 0 is 1. Okay, 0.8 to the power of 1 is going to be 0.8. Okay, so hopefully that should give you some sense of direction, that when you pop this into a calculator, you've basically now, the next one is going to be 0.8 squared. So the 2 is going to go there, 0.8 squared. Well, that's going to be 0.64. 0.8 cubed is going to be 0.512 to the power of 4 is going to be 0.41. Okay, to the power of 5 is 0.33, and to the power of 6 is 0.26. Okay, so hopefully that'll give you sufficient to be able to plot it on this particular graph. Now, as you've noted from my previous question, my drawing prowess isn't particularly good, but hopefully this will give you some idea. Okay, so I'm okay with that one, and I'm okay with that one. All right, so the rest of it is probably going to go a little bit astray, but we'll give it our best shot. So 2 and 0.64 is going to be there. 3 and 0.512 is going to be roughly about there. Okay, 4 and 0.41, 4 and 0.41, well, it's going to be about there. Okay, 5 and 0.33 is about 0.3. 3 is roughly about there. Okay, and then 6 and 0.26. 6 and 0.26 is there. Okay, so we're able then to draw the graph of y equals 0.8 to the power of x to the values, from the values of 0 to 6 is going to be, this is where it's going to be a little bit tricky on this particular video, but I'll give it my best shot. So I'm going to come all the way down like that, and that would be the value, and that would give you full marks on that particular question. Okay, let's move on then to a little bit more work on graphs. No, sorry, a bit more work on algebra. Okay, so it says Amy has X beads. Okay, Billy has 3 more beads than Amy, and Carly has 4 times as many beads as Billy. All right. Okay, so circle the expression for the number of beads that Carly has. Okay, so what we've got to do is we've actually got to say, well, in that case, we've got Amy. Okay, we've got Billy, and we've got Carly. So Amy has X. Okay, Billy has 3 more. So X plus 3. Okay, and then Carly has 4 times as many beads as Billy, so it's 4 times x plus 3, which you'll notice is going to be this one here. Okay, so that would be the answer to that particular question for 1 mark. Okay, so number 16 then. So hopefully please do stop the video, have a go at each of these questions, then compare your solutions. So number 16, 2 straight lines intersect at point A. Okay, that's fine. So this is one of the straight lines, y equals minus 4x, and this is the other one, y equals 3, and it intersects at that point. Okay, that's point A. Circle the coordinates. Well, basically, it's one of those sort of tricky questions, I guess, because what we're saying is that y equals 3 and y equals minus 4x. So we could, if we want, write minus 4 equals 3. Minus 4x, sorry, equals 3, okay? Because they both equal y, then minus 4x must equal 3, because they both equal y. So therefore, if we want to find the value of x, what we do is we divide both sides by minus 4. So if I divide by minus 4 both sides, I get x on its own equals 3 over minus 4, which is the same as saying x equals minus 3/4. Okay, so hopefully you can see that the only coordinate that's got minus 3/4 in it is this one, and that's going to be the correct answer. It's going to be minus 3/4 and then up to a value of y, which is 3. Okay, so the second part of it will have to have 3 in it, which it does on all of them. So the key to this is making sure that you kind of figure out that both must be equal to each other, and then use that information to be able to work out the value of x. Okay, so let's move on to question number 17. Okay, we're about 15 minutes into the video now. Okay, so this one is a bit of a long one. Okay, but we'll give it a go. It's one of those newer topics that came in with the change in the curriculum around about 2016, and it's called something like product rules for counting or something like that. Okay, so if you want to have a look at that. So here are two methods to make a 4-digit code. Codes can have repeated digits. Okay. Method A is for the first 2 digits, use an odd number between 30 and 100. Okay, so the first thing is we're going to have to figure out how many odd numbers there are between 30 and 100. Okay, we'll do that in a minute. And then for the last 2 digits, use a multiple of 11. All right. Okay, so let's have a look at the number of odd numbers. Okay, so what we've got really, and I'm going to try to kind of work through this relatively methodically. So method A. Okay, now what we need to do is we need to work out the number of odd numbers between 30 and 100. So what I'm going to do is I'm going to work out the number of odd numbers between 30 and 40. Because if I do that, then I can just duplicate that information for then all the groups of odd numbers all the way up to 100. Okay, so between 30 and 40, well, there's 31, 33, 35, 37 and 39. So there's actually 5 of them. Okay. So therefore, the number of odd numbers between 30 and 100, I can say, well, we got 5 here, okay? And then I'm going to have 41 to 50. Well, that's another 5. And then I'm going to have 51 to 60, 61 to 70, 71 to 80, 81 to 90 and 91 to 100. So actually each of those is a group of 5. Okay, so I've got 5, 10, 15, 20, 25, 30, 35. So the total would be 35 odd numbers. Okay, right. Okay, the second one is I've got for the last 2 digits, use a multiple of 11. Okay, well, between 11 and 99, there are 9 multiples of 11. Okay, so my number of odd numbers is going to be 35. And then I've got 11, 22, 33, 44, and so on, all the way up to 99. So actually, my number of combinations is going to be, or number of codes, if you like. So method A, number of codes is going to be equal to 35 times 9, which is equal to 315. Okay, so there are 315 different variations of my codes. So I could have, let's say I could have 3111, or I could have 3188, or whatever it might be. There's 315 different types of combinations I can use just for method A. All right, method B, use 4 digits in the order even, odd, even, odd. Okay, do not use the 0 digits. Okay, that's fine, no problem. So let's have a look at that then. So with method B, I've got a slightly different situation where I've got a choice of 4 even numbers, 2, 4, 6 and 8. I've then got a choice of 5 odd numbers, 1, 3, 5, 7 and 9. I've then got a choice of 4 even numbers again. And then I've got a choice, finally, of 5 odd numbers. Okay, 7 and 9. All right, so in other words, my different combinations for method B, okay, so method B is going to be 4 times 5 times 4 times 5, which is actually 400. So there are 400 different combinations that I could use for method B versus 315 for method A. Okay, so to answer the question, which method gives the greatest number of possible codes? Well, it's going to be method B. All right. Okay, quite a tricky one to kind of work through. I'm not sure whether we should sort of finish on that. Okay, I tell you what, let's do one more and let's see what happens with question number 18. So hopefully you're okay with that. Do have a look at some of the playlists. There are a couple of videos, I think, on product rule for counting. And these sort of questions do come up in GCSE. Not very often, but they are becoming a bit more popular. Okay, so let's have a look then at question number 18. So this is back onto kind of algebra ground, really. And it says, show that for when x is greater than 0, or not equal to 0, when x is not 0, this can be written in the form that. All right, well, basically what we mean is that if we're subtracting two fractions, we need to make sure that the denominator is the same. Okay, now at the moment, one of them is 3x and one of them is 2x. So what I need to do is I need to multiply through in order to make the denominator the same. So how do I get 6x here? Well, if I get 6x here, what I do is I multiply through by 2, okay, because 2 times 3x is going to be 6x, okay, so I'm going to multiply this bottom one by 2, which is going to give me 6x, but because I've multiplied the bottom by 2, I have to multiply the top by 2 as well, so that's going to be 2 times x plus 4, okay. And then I'm going to minus that from the bottom one, where I'm going to multiply it this time by 3, okay? Because 2x times 3 is going to give me 6x, okay? So 6x is the common denominator, the lowest common multiple of 2x and 6x. So that's going to give me 6x, and the way it's done that is because I've multiplied by 3. So I need to multiply the top by 3, which is going to be 15. Okay, so let's just tidy this up a little bit. If I bring them together over the same denominator, I've got 6x at the bottom there, okay? And then if I multiply this out, I've got 2 times x is 2x plus 8. So 2x plus 8 minus 15, okay? Tidy that up even more, it's going to give me 2x minus 7 divided by 6x, okay, and you'll see that it's in the same form, okay. Now I had a comment the other day about this being a positive and the actual answer being a negative. It doesn't matter at all. It just means the value of b is going to be, in this particular case, minus 7. So in this case, if you wanted, you could say a equals 2, b equals minus 7, and c equals 6. And that would be absolutely sufficient to get you your full 3 marks. Okay, I hope that's been okay for you. It's 22 minutes or so into the video, so I think we shall stop there, take a bit of a break. Please do add a question below if you're not sure about anything. I'll always come back to you. Have a look at some of the other playlists within this particular channel, and I'll look forward to seeing you inside the next video, where we're going to start from question number 19.